Let's look at a couple other examples of the mean value theorem. So let's say that we have a graph that looks something like this, and we have a function. I'll draw the other arrow and the 0 here. And we have a function maybe that looks something like this. If this is A on this side right here, and this is B right here, and if I draw a line that connects these two endpoints, so let's go ahead and draw that line, and that line, the slope of that line, we'll call that M. The slope here is equal to f of b, which is this value right here, f of b, minus f of a, and that's this value right here, f of a, over b minus a. And this is what we're going to start off with. So I'm just going to draw that line. The mean value theorem tells us that somewhere here, we can call this perhaps here at this point maybe C1, and let's choose another and have another point here, C2. The mean value theorem tells us that there are at least one point on this function f of x such that the derivative of f of x at this point, the derivative is equal to the slope of this line connecting the two endpoints. And here we can kind of see that, right? We can see that the slope at f of C2, so the slope there, f prime, is equal to our slope of the line connecting the endpoints, m. And we can see right here, where f prime of C1 also is equal to the slope of the line that connects our two endpoints. And so all the MVT does is the MVT guarantees that at least one point between A and B has the same slope as the line connecting the two endpoints. Let's go ahead and look at another example. Let's say that I have a function that looks something like this. And I'm going to go ahead, once again, we're going to look at this from the interval a to b. I'm going to go ahead and draw a connecting line like this. And all the mean value theorem says is that between a and b, there is at least one point C. Here it looks like we have multiple points C, but there's at least one point C where the slope of our function f of x is the same as the slope of our line that connects the two endpoints. And we call this line right here, we call that a secant line. So a secant line is the line that connects the two endpoints of a function. And so once again, the mean value theorem, all it says is that there is at least one point C. Here we have a C1, a C2, a C3, a C4, and a C5. But the mean value theorem guarantees that there is at least one point C in between A and B, such that the slope of f at C is equal to the slope of the secant line.